All right, ladies and gentlemen, this is our 9th presentation in chemistry. This week we will be talking about how to write chemical equations and learning how to balance those chemical equations based on the idea of conservation of mass. So that's the idea that we're going to be working on this week. Okay, so here we go. All right, so last few weeks we've been talking about chemical bonding and how atoms like to combine with one another. Well, when they do that, what we do is we actually write out an equation, or it's a way of describing how chemicals bond and how chemicals react with one another. Right? So it's not math in the sense of like when you use the words equation and stuff like that. The way we use it as just to describe what happens when you mix chemicals together. And instead of a equal sign like you see in math, we use an arrow. An arrow signifies that something is turning into something else, right? So what we use it for basically is to show how molecules chemically combine with one another, right? And we'll talk a little bit more about this on the next slide. But the stuff on the left side of the arrow, these are what's called a reactant. These are the things that we start with. So these are the things that we start with, right? And then ultimately, these things will turn into these things. These are your end products, your end stuff. Okay, we call these the products in this case. So this is actually what we call the decomposition of hydrogen peroxide, H2O2. That's hydrogen peroxide. You start with that, and it will break down into water and oxygen. Right? I actually did this experiment for you guys in class where you got that big giant puff of smoke. So that's one of those things. But anyway, this is what we're going to be doing this week, is talking about now. We're going to be getting away from that whole chemical bonding stuff, and this one we're just going to talk about how to describe the chemical bonding. Okay, so all right, so let's get a little dig deeper and talk about what is a reactant. So reactants right here, right? These are, again, the starting materials in a chemical reaction, right? And these are always on the left side of the arrow. So it's really, really simple, right? Left side, right side, and so on. The reactants are there. And then we got the products. These are our end things again. These are the things that are formed through a chemical reaction, right? Again, it's the end product. So I have two different chemical reactions right here, right? These are my reactants, everything that is on, right? So the ones right here, right? That's nitrogen and oxygen. And when it combines together, it makes nitrogen trioxide. All right, again, this is another, because these are all on the left side, so there's two reactants. Since there's a plus sign right here, so again, a plus sign indicates that there's another molecule. All right, so it's the nitrogen molecule plus, right, just like math, plus an oxygen molecule. These are the two that combine to make this. All right, same with this one. This is methane, CH4. Right, the molecule CH4 combines with oxygen to make, and that's what this arrow means, to make carbon dioxide and water, right? And everything on the right side, right, these are our products. So pretty simple in that sense to know that, okay? So these are our products. All right, so just kind of how a really, really quick way to tutorial on just how to write chemical equations. All right, so now what we need to talk about next is about what's called conservation of mass, right? And how does that relate to how we write our chemical equations? Because some of you guys may have noticed, if you were looking at the equations, that they might not make sense to you a little bit, and we'll talk a little bit about that. But basically what the law of conservation of mass states is that all mass of the reactants must equal the mass of the products. What that means is, if I weighed all of my items at the very, very beginning of the chemical reaction, or all the chemical bonding that's going to take place, right? At the end of that chemical reaction, I should have exact same weight, right? Or the mass at the end. Because what it's saying is you can't lose the weight. It doesn't just go away. So another case, let's say that, here's another example. Here's water. All right, hydrogen combines with water, or oxygen, to make water. So if I start off with 50 grams of hydrogen and 25 grams of oxygen. So that's total, right? In total, I have 75 grams right here as the reactants, right? Ultimately, that 75 grams should make exactly 75 grams of water. That's what we call the conservation of mass, all right? So that's the idea. So when we do our lab this week, one of the labs that you're going to do is you're going to be taking the stuff at the very beginning, and then when chemical reaction takes place, you're going to weigh it again. You should ultimately see that the weight should stay exactly the same because of the law of conservation of mass. Okay? All right. So with that being said, the way this equation is written, making water, it's written incorrectly. All right? And I'm hoping that some of you guys are looking at it going, yeah, something is weird about this. Okay? And the question is why? Why is this equation written wrongly? All right? Because right now this is not fit. This does not go with conservation of mass. All right? And the ultimate idea is that if we look at it, right, the reason why this is wrong is because the amount of atoms on the reactant side don't equal the amount of atoms on the product side. Okay? Meaning that what happens is you have hydrogen here, you have oxygen, makes water. I'm hoping that some of you guys are sitting there going, wait a minute, what happened to that other oxygen, right? I had 2 oxygen atoms to begin with. Why don't I have 2 oxygen atoms on this side? And that is the reason why this right here, this equation, is wrong, right? In reality, and I'm going to do this very, very quickly. I don't expect you to do this really, really quickly right now. But in actuality, what I need to make it so it's balanced is it's going to look like this. This is now a balanced equation. So basically what I'm saying is, and again, I'll go through this quickly, or right now, and I'll do this slowly. The idea is that I will need this. This is how I make a balanced chemical equation. I actually have 2 hydrogen molecules, and I add that to 1 oxygen molecule, and that makes 2 waters. So really what I'm trying to tell you is water is never made singly, right? I don't know why I did that. Okay. You always make water in pairs, in molecules. This is what we call a balanced equation, right? Why? Because I have now, even though I started with 2 hydrogen atoms, I now have 4. 1, 2, 3, 4. But on this side I have 1, 2, 3, and 4. I have 4 atoms on that side of hydrogen. Over here I've got 2 atoms of oxygen, 2 atoms of oxygen. So that makes this what we call a balanced chemical equation. Not every equation that you're going to get at first is going to be a balanced equation. We call that a skeleton equation. All right? So now let's go through the process of how I did this. All right? For some of you guys who are really math-minded, this is going to come to you naturally. All right? But some of you guys who might struggle with math a little bit, you might have to go through the steps that I'm going to go through to ensure that you're getting the right answer all the time. Okay? So there's 3 steps, all right, really of going through this to making sure that we do this correctly. All right? And step 1 is we want to draw a box around each molecule. Okay? There's a significant reason why we do this. All right? And the idea is, what you're trying to say is that you cannot touch what's inside the box. Because I'm going to tell you right now, most kids do this. They go, okay, why can't I just do this? Why can't I just put a 2 there? If I put a 2 there, now I have 2 oxygens, I'm done, right? And the big answer is because now I'm not making water. H2O2 is hydrogen peroxide. That's the stuff that you put on your cuts, right? I doubt you really want to drink that stuff. And that's the reason why you can't do that. Because when you change the things inside the box, then you change the entire chemical. And we can't change the chemicals that we have. All we can say is we can make more of those exact molecules. All right? So that's the first step. Step 1 is just making it. So again, if this is kind of a visual representation of what you see, right? I'm basically going like this and saying I cannot change this. This is what I have. I can't change the way these things are bonded. Okay? That's just the way it is. Again, the biggest mistake that some kids make is they'll do this. They'll go, why can't I just do this? Okay? Again, if I did that, I'm completely changing this entire thing. It's not water anymore. All right? So I can't change anything that already exists. All right. So that's step one. Step two is now I need to list out what I have. So in other words, what I'm going to do is I'm going to look through each one of the atoms I have. So I'm going to make a reactants, and I'm going to just go reactants like this. I'm going to go R, and I'm going to put P, just because I don't want to write all the stuff out. And what I'm going to do is I'm just going to take an inventory of how much of each atom I have. So on the reactant side, I have hydrogen atoms, I have oxygen atoms. On the product side, again, same thing. I'm going to have hydrogen and oxygen. All right? I shouldn't have anything different from the reactants product. But what I'm going to do now is I'm going to just count how many of each atoms I have. So hydrogen. Since there's a 2 right here, it tells me I have 2 atoms. Over here, same thing. I have 2 atoms of oxygen. Over here, I have 2 atoms of hydrogen because H2O. So remember, this 2 only goes to hydrogen. Okay? O, that's a 1 right there if we don't write that. So now oxygen only has 1. And you always ask yourself this question. Are the amount of atoms equal on both sides? No. Okay? Now my hydrogens are. I have 2 hydrogens on both sides, which is fantastic. All right? But if I look at it, I have 2 on one side and 1 on the other. And based on law of conservation of mass, this equation cannot be written the way it is. All right? So that's what I'm going to do. I am going to list out all that stuff. And now that I know that this isn't exactly everything, oops, I want to do that. Okay. Let's just go like that. All right. I'm now going to sit there and I'm going to now go to the third step. And the third step is basically what it says is I'm going to place a coefficient in front of the molecules. Okay. So I should have kept that chart that I had, but that's okay. I'm going to write it back out. It's pretty quick for me to do this. All right, it'll give you time to write everything out anyway as I go through this. Let's do this real quick. Hold on 1 second. Sorry, guys. And oxygen equals 2. Hydrogen equals 2 on this side. Oxygen equals 1 on this side. All right. So now what I'm going to do is I'm going to place a coefficient. In other words, I'm going to put a number out front right here. Because remember, I can't change anything that in my molecules. I can't change anything inside the box. All I can do is I can put a number out here saying I can add more of those molecules, all right, into my equation. All right? So right now I have 1 hydrogen, 1 oxygen molecule that makes 1 water. And we know that this doesn't work because right now I have 1 too little oxygen on this side. So here's what I'm going to do. I'm going to sit there and go, okay, well, guess what? I am going to multiply this by 2. What that means is I get to multiply everything inside this box. In other words, I am making another water molecule. Okay? When I do that, I'm going to now go back right here to my chart and I'm going to change everything up. Now I have what? 1, 2, 3, 4. I have 4 hydrogens. Right? And I have 2 oxygens. Now, I did that, and now my oxygens are great, right? I balanced my oxygens out. Here's the problem. By doing that, I messed up. What I used to have was I had synchronized hydrogens over here. Now I don't. I have 4 on this side and 2 on this side. So I'm sitting there going, okay, what can I do to my hydrogen here? Well, I can get another hydrogen. I can put a 2 right there. Now I'm saying, hey, I got 2 of these. All right? So what this means is, in ratio terms, every single time I want to make water, I have to have 2 hydrogen molecules. So here's 1 hydrogen molecule, here's another one. And I combine that with 1 oxygen molecule that creates 2 of these. So I have a ratio of 2, 1, 2. Now, some of you guys might be sitting there going, why didn't you write anything? Well, it's like math, right? I can put a 1 out there if I want to, but it's just like math. Do I really put 1x and so on? And again, going up down here, this is what I do. Now, this is not my answer. My answer is this. This is my overall answer right here. That's the equation that I'm trying to get. This is the work it takes me to show this. Now, some of you guys are going to look at it and go, I don't need to do this to get this. I can do this in my head. And you're probably right. You can probably do this without having to do all this stuff. But I'm going to tell you right now, I want you to get in the habit of doing this. When you guys get to chemistry and you have to do this, this is what I call easy stuff. All right? These are easy equations. You're going to get to very, very difficult equations where you're going to have to do this, or else you're going to have a very hard time. All right? But this is what we call balancing equations, and it meets the idea of conservation of mass. Okay? All right, let's do another one. All right, let's do some more. All right, here's the reaction. Magnesium oxide will break down into its two atom parts, magnesium and oxygen. Okay, so the first thing you're going to do, just like last time, is we're going to put a box on it, each one. Now, as you get better at this, you're probably going to start skipping this step, and that's fine. All right, but for now, I want you to do it just to give you an idea of, hey, I can't touch anything that's inside that box. All right, so next step, I'm going to make my inventory, right? I'm going to look at it and I'm going to go, okay, I got magnesium atoms out here and I have oxygen atoms. On this side, the reactant side, I've got one each. On this side, I've got one magnesium, but I have two oxygens. So that's where my difference is right here. I've got one here, two there. So this is a pretty quick fix that I can do really, really quickly. So I got one oxygen here. I can just multiply this by 2. In other words, what I'm doing is I'm saying I'm creating another one of these molecules, right? So now when I do that, I now have 2 oxygens. However, remember, I have to multiply everything inside of this box by 2. I can't just say I just need an extra, oh, there you go. No, I created another magnesium. So now I have 2 magnesiums, all right? Now, that does mess up my magnesiums. Even though I made my oxygens good, my magnesiums are now off. I have 2 on this side, 1 on this side. Again, I come over here and go, there's magnesium. What do I need to do? Just multiply it by 2. Because now if I do 2 times 1 atom, right? So basically what I'm doing is I'm taking this and I'm going, I need this. When I do that, I now have 2 magnesiums. And there you go. Everything is equal. Remember, you're always asking yourself, are the atoms on my reactant side equal to the atoms on the product side? And in this case, 2 equals 2, 2 equals 2. And this right here is my answer. All right, so in other words, to make magnesium and oxygen, I need 2 magnesium oxides, and those will break apart into 2 of these and only 1 of those. Okay? All right. Let's try another one before you try to do one on your own. All right, here's now nitrogen and hydrogen combining together to make ammonia. All right, so first thing again, right? And hopefully as you get better at this, you don't have to do this so much, but putting a box around everything. All right, again, the idea is for you to say, I cannot touch anything that's inside that box. All right, I can only put a number out front to say I can make another one of those molecules. All right, so now the next thing we're going to do, right, is to make our inventory. So reactant side, product side. So now I'm going to sit there and go, I've got nitrogen atoms and I've got hydrogen atoms on both sides. Let's count. So on this side I have 1, 2. Again, how do I get that? I have a visual here, but I also have a 2 here that tells me I have 2 atoms. Hydrogen, got 2 atoms. Over here, I've got only 1 nitrogen. Again, remember NH3. It's really an N1H3, but you don't say the N1. And then H3, that means I have 3 hydrogens. Okay? So, I'm going to look at it and go, all right, I've got nitrogens that are messed up. I've got hydrogens that are messed up. The question becomes, where do I start? Right? What I want to do is I want to first do my nitrogens. I want to see if I can get that. So what do I do over here? I'm going to put a 2 out in front of it, right? Because if I did that, I multiply everything inside here by 2, which means instead of having this, I now have 2, right? So basically what I did was I made another one of these. So now I have 2 ammonias, NH3s, right? But if you look at it, when I make this and I duplicate this, I not only made 2 nitrogens, what did I also do? I also created more hydrogens, right? So I did 2. Since there was 3 here, I'm doing 2 times 3. So now I have 6 hydrogens, right? 1, 2, 3, 4, 5, and 6. All right, so now my nitrogens are good. My hydrogens are messed up, right? I've got 6 over here, 2 over here. What I need to do is I need to multiply this side by 3 because I have 2 on this side. 2 times 3 equals 6. So now I've got this. So really, in actuality, so if I do this, I'm going to take this out, right? And I'm going to take another one out. So for this experiment to take place, I need 1 nitrogen atom, or molecule, I'm sorry, and I need 3 hydrogen molecules to make NH3. All right? And so, again, my answer is this right here. All right? So this entire thing is my answer. Again, remember, this bottom part is not my answer. It's just my work to get to this point. This is the answer that I'm trying to get. This shows a balanced chemical equation. Right? Now, I want you to try this one on your own. So I want you to pause it, okay, and go through the steps. So, and then I'll come back and I'll show you what the right answer is. All right, so hopefully you paused it and you finished it and you're sitting there going, I feel like I did a good job with it. All right, so that's the case. So again, let's start off by putting a box around everything because, again, we're saying we cannot change these molecules. Right? We can only change the number that goes on the outside. So now we're going to take an inventory. Now this time, you should notice that you should probably, instead of 2, we have 4 different types of atoms. Right? On both sides. O equals, BE equals, and F equals. Now on this side, I have 2 lithiums, 1 oxygen, 1 beryllium, 2 fluorines. On this side, I have 1 lithium, 1 fluorine, 1 berylliums, and 1 oxygens. Right? 1, 1, 1, 1, everything. And I have 2, 1, 1, 2 here. So let's say I want to first fix my lithiums. All right? So lithium is here. I have 2 on this side, 1 on this side. So I come over to the product side, and I put a 2 there, right? That will make it, so now I have 2. But remember, I now have 2 F's because I multiplied everything in this box by 2. And look at that. If you notice, I'm going lithiums are 2, oxygens are 1, 1, berylliums are 1, 1, and my fluorines are 2, 2. Just by doing that, I'm done. So here's my answer. Boom. All done. All right, so this one was actually a really, really easy one, even though this one had many, many more atoms I had to deal with, but it was a quick fix. Okay? All right, so this is the end of the notes. What I want you to do is, there is one link on my website, is for you to practice a little bit more of balancing chemical equations. So just try that website out and do a few of them, and once you get the hang of it, you can stop. Okay? All right, there you go. Congratulations.